Let's understand how to calculate material mix and yield variances. Okay, so first of all, in order to calculate material mix and yield variances, we have to understand how to build the pro forma for the material mix and yield variances. As you are already aware of, and you learned it in your previous basic courses of management accounting, that mix and yield variances are sub-analysis of the material quantity or usage variances. So we actually start with the usage variance to build onto the pro forma of the material mix and yield variances. So starting with the material usage variance, which is the difference between standard quantity and actual quantity. So standard quantity times standard price minus the actual quantity times standard price. So prices are always kept at standard as a constant. So the difference for the usage is only between standard quantity and actual quantity to produce the actual output. Now, this is the usage variance pro forma as a basic variance. So what I'm going to do is, can you see what I did? Well, yes, the second line, which was actual quantity into standard price, I copied and pasted one more time. And now I'm going to build some more elements into this pro forma. So in the first line, please have a look, standard quantity at standard mix. Now, what is standard mix? Standard mix is the standard proportion of each ingredient in a product. In a number of situations, we are given standard mix as a percentage, like we mix 60% of A with 40% of B, or 70% of material A is mixed with 30% of material B, so that 70% and 30% or 60% and 40%, for example, would be defined as standard mix. Or instead of percentages, we can also be given standard mixes as the quantities, like in this example. Can you see that there are two materials being mixed together, A and B? So material A quantity is 2 liters, material B quantity is 3 liters, and the above mixture of 5 liters, so 2 plus 3, 5 liters. So in order to produce the product, we mix 2 liters of A with 3 liters of B. So SM in this pro forma will be 2 over 5, and SM for the material B will be 3 over 5. You can work out the percentages. 2 over 5 is like 40% and 3 over 5 is like 60% if you fancy. Then same SM goes into the next line. Here actual quantity is considered as total actual quantity of materials used. So if I take you into the scenario and explain what is AQ, can you see the second last paragraph? During the period, actual usage was 250 liters of A and 300 liters of B to produce the actual output. So 250 liters of A plus 300 liters of B, if you add them together, so the total quantity of mixture was 550 liters. So here the AQ will be 550. Then actual quantity times actual mix. So actual quantity, actual mix is nothing but the actual quantity actually mixed. So here from the question, 250 liters of A and 300 liters of B will be used as AQAM, actual quantity, actual mix. Right? These abbreviations I explained already, but just for your comfort, I have put them in one page so that you can refer to them sometimes later on as a revision. Now the questions you have already seen actually, but now let's go through one more time. So we produce some product like paint by mixing 2 liters of chemical A with 3 liters of chemical B, and the standard costs are given $3 per kilo and $4 per kilo. The above mixture of 5 liters is expected to produce 4 liters of paint. So if we put the input of 5, we get the output of 4. So there is 1 liter of loss out of 5 being wastage. I think, yes, you are very mathematical and your brains are telling you that the loss in this process is about 20%. During the period, actual usage was 250 liters of A and 300 liters of B to produce actual output of 450 liters of paint. So you can make a screenshot while you are listening here before I start calculating the material mix and yield variances. With the help of that screenshot, all numbers you will be able to notice how would I build the pro forma. So let's start, shall we? Okay, so that was the pro forma which we now insert the numbers into. So here goes. The most easiest things for me always is the standard price. Here goes. Can you see that? The standard price of material is $3 per kilo or per liter, and for B is $4 per liter. Then the next is the standard mix, which is 2/5 and 3/5 of A and B respectively. Then the SQ, standard quantity. Here goes. Now, can you see how did I develop 562.5? Okay, what is it actually? Well, this is standard quantity to produce the actual output. Standard quantity to produce the actual output. Now, what was the actual output? Remember that? Actual output was 450 liters. And what was given? We use 5 liters to produce 4 liters. So if we mix 5, we get an output of 4. So 80% is the conversion ratio. So there are two ways. 450 liters times by 5 divided by 4, and that gives me my favorite number, 562.5. Or what you can do is 450 output divided into 0.8 or 80%. I get pretty much the same. Okay, then all we need to do is now multiply these numbers across to get something like that. Then the next thing to build would be actual quantity, which is already given, copy and paste. 550 liters, which is the sum of A and B actually used. Then multiplied by 3 and 4, we get that. Here goes. Now 2025 minus 1980 gives us the yield variance being favorable. Why is it favorable? Because instead of mixing 562 liters, we only mixed 550 liters to produce 450 liters of output. So the standard loss was about 20% of the input, but the actual loss was slightly lower than 20%. That's why our yield was favorable. Then all we need to do is pick up actual quantities given in there, which is 250 and 300. Okay, 250 and 300. Just let me double check that one. 250 and 300. Okay, then all I need to do is multiply them across, and we get something like that. And then the difference between 1980 and 1950 gives me $30 of favorable variance. Why mixed variance is favorable? Simply because they used little more extra of A by removing some of the material B. So material A has replaced little bit of material B, and as material A was cheaper, that's why it gave us the favorable mix variance. Thank you.